In this video, we are moving on to a different topic. We're moving into our lessons on statistics. And to start us off, we are looking at scatter plots and association. So in this lesson, we're going to talk about what are scatter plots, why are they used, and what are associations, otherwise known as correlations. And we're going to determine what makes associations positive or negative, and linear or nonlinear. We're also going to be taking a look at how scatter plots are used in the real world, and they are used a lot. So let's get into it. So a scatter plot, as you see on the right, is a graph with points plotted to show the relationship between two sets of data. So you have a bunch of data points in this graph, and we are looking at the relationship between the height of a dog in inches and the weight of the dog in pounds. In any scatter plot, you're going to find terms such as clusters and outliers. So a cluster is a set of closely grouped data, and data may cluster around a point or along a line. So just for example, in the graph that popped up in the bottom left, we are looking at basketball shooting, shots attempted versus shots made. And so I'm seeing two clusters, groups of data that are very close to one another. And in scatter plots, you're also finding outliers. Outliers are data points that are very different from the rest of the data in the set. For example, in this basketball graph, the point on the far right is very different from the other groups of data. This is what we call an outlier. You can also see some outliers in the graph showing dog height versus weight. You're seeing some outliers that are very far past the trend in the data. So let's take a look at another one. We are told that the final question on a math test reads, how many hours did you spend studying for this test? The teacher records the number of hours spent studying and the test grades at the end. So we're going to take the table shown with all of her data, and we're going to make a scatter plot of it. It says to graph hours spent studying as the independent variable or the input. So hours spent studying is X, and the test grades are the dependent variable or output, which we use as Y. So I'm going to go ahead and plot those points, and you see them here. And then I'm also going to try and fit a trend line to this data. And that's about what my trend line would look like. Again, the big bold red line is what we call a trend line. It's the line that best fits the data. But you'll notice that some of the data doesn't necessarily fit. You've got a couple points, especially this point on the right, that is definitely an outlier. So we can use the data in this scatter plot to determine the association between hours spent studying for a test and the overall test grade. Now, what's really important is that we're interpreting this wisely. This is one scatter plot with data from one class. We don't know where this class is. We don't know what content was taught for this test. We only know the hours spent studying and the test grade. So while it may look like as the hours spent studying increases, your test grade increases, that's not always true. So we got to interpret our data wisely. So now we're going to look at determining the association in the data, and I gave you a sneak peek to that already. The association is how sets of data are related. So in the graphs up top, we're looking at positive association first. So let me label my axes on all these graphs. My left to right axis is my x-axis, and my vertical axis is my y-axis. And so we can determine associations by drawing trend lines. So in a positive association graph, the line that we can draw is a line that has a positive slope. And we know that as x increases, as the x variable increases, as we move left to right across the graph, y also increases. That means as we move left to right on the graph, y is moving upward. And so for a negative association, the opposite is true. In a negative association, as x increases, as we move left to right across the graph, y actually decreases. Y goes down. And the reason why it's called a negative association is because the trend line in our data has a negative slope. So positive association has a trend line with a positive slope. Negative association has a trend line with a negative slope. And then let's look at a graph with no association. I'm seeing points that are all over the place. I can't really fit a line to all of the points in this graph. So there's no obvious trend in this data. So this is what we call no association. So let's examine in depth a different example. So the plot shows the reading level and height for 16 students in a district. We're asked to describe the association and give a possible reason for it. So what I'm seeing, if I were to draw a trend line through this data, this is just a rough sketch, it's not going to be perfect, and I'm going to try and fit it through the data as best as I can. So this would be my trend line, and I am noticing that the line I drew, as x increases, y also increases. So this is a positive association with a couple outliers. So since this has a positive association, we're basically saying as reading level increases, height also increases. But it's extremely important to realize that reading level does not cause you to grow taller. Height does not cause you to have a higher reading level. There are other factors that are associated with these changes. The one that's coming to my mind right now is, well, as you grow taller, your brain is also developing. You start out really small as a baby, and then when you get into middle school, you're obviously much taller, and you're able to read at a higher fluency because your brain has developed. It's not necessarily tied to reading level or height. One variable does not necessarily cause a change in another variable. It's extremely important that when we're looking at scatter plots, that we are paying attention to that. Here are some examples of associations, and these are not the most strongly tied correlations or associations, but here are some examples I came up with. So for a positive association, we are examining the relationship between hours, let's say hours per week spent in the gym versus a person's overall muscle mass. So the trend is that as the person's hours spent in the gym increase, muscle mass increases. That's the association between the data. In a negative association, here's another example. we're looking at the miles driven in a car versus the total gas in the car's tank. So as you are driving, as the miles you drive increases, that means the gas in your tank decreases. And for no association, there are lots of examples of these, but I chose the relationship between hair length and student height. Obviously, there is no association because you can be very tall and have a buzz cut, or you can be very short and have hair past your knees. You can cut hair. Hair does not influence your height. So I want to show you some examples in the real world. This specific example is looking at the number of students per qualified teacher versus the gross domestic product, basically the wealth of a country. So what I'm seeing here, if I'm looking at the trend, it's not exactly linear. It's a non-linear association. And what I'm seeing is that as the gross domestic product per capita of the country increases, the number of students in each class decreases. So this is a negative nonlinear association. Scatter plots are used in worldwide and countrywide data all the time, and it's such a powerful graph. Here's another example determining the relationship between the human rights score of a country versus the gross domestic product per capita, or essentially a measurement of the wealth of the country versus its human rights score. And then I wanted to bring a very relevant example to the table. Right now, this is the total confirmed COVID-19 deaths versus cases as of the day that I'm recording this. So this is if the scales on the X and Y axes are linear. And so I'm seeing a positive association here. And if I change both of the axes to logarithmic or exponential scales, you're seeing a much more visually aesthetic positive association in the relationship between the total confirmed cases of COVID-19 and the total confirmed deaths due to COVID-19. Again, not all of this data is not all of this data is the most accurate because there's limited testing for this disease right now, but you are seeing a positive association in this data. So I got all of these real-world scatter plots from a website called ourworldindata.org, and I searched for articles by topic. And so there's thousands of reports. Not all of them are scatter plots, but all of these results are very powerful, and I highly encourage you to take a look on your own time and see there's a lot of powerful data sorted by social issue. So as a summary, we looked at scatter plots and determined associations. So you see positive association as X increases, Y increases. Negative association as X increases, Y decreases. And no association means we cannot draw a trend line, or there is no obvious trend in the data. One more thing, when you interpret data, definitely interpret carefully. Correlation is not causation. Yes, there may be some very powerful relationships in specific variables, but it's important to determine a broader scope of reports when you're coming to conclusions about sets of data. I hope you found this helpful, and I hope you have a wonderful day.